Hello, my name is Sebastián Mayorga and this is my final project for the subject of automation by the name of Rotary Machine Automation for Filling and Sealing Cream Cheese. This is a rotary machine with several stations which objective is to fill containers and seal them before storing them. In this case, this project is a proposed solution for the real industrial problem the company San Julián is having. This company produces cream cheese like the one on the image. Right now, they are having three main problems with this machine. The machine works based on a camshaft. This activates sensors that open and close electrical valves that control pneumatic cylinders, besides other mechanical components. So everything depends on accurate mechanical synchronization that tends to fail. This means that the machine spends too much time in maintenance, slowing down production. And since there are many mechanical parts, the wear they suffer also affects the performance of the machine. In this video we can see how the camshaft works. As it rotates, it is turning on and off all the different sensors that then send signals to the electrovalves. So the proposed solution consists of replacing the camshaft system for a PLC control electro-pneumatic system in order to eliminate mechanical synchronization, increase productivity. We're going to reduce human interaction because the machine is going to be able to do all the complete cycle by itself, and we're going to have the possibility of customizing the operation of the machine to the needs of the company, since the only way of doing this right now will be to do some kind of change in the mechanical way things work. So as part of the proposed solution, I am proposing as a PLC a modular control system CPXE from Festo. It has 16 digital inputs and 8 digital outputs. I'm proposing a standard pneumatic cylinders from Festo, double action cylinders with a standard profile and with 2 sensor slots. For the first station, a vacuum cylinder is needed, so I'm proposing a VC vacuum cylinder. For this project, I use Festo Fluid Sim to design and analyze the pneumatic circuit. I used codices to simulate a virtual PLC and to write the code, and I use Autodesk Fusion 360 to design the animation. In order to have a better idea of how this process is working, I'm going to show you the following animation. The first step is placing a container on the rotary table by using a vacuum cylinder. After each station, the rotary table moves one position. Then we fill our container with product. After that, we place a metallic sheet, so then we can seal with heat. After that, we place a plastic lid on top. And finally, we can extract our finished product from the rotary table and we can send it to storage. Here I have the representation of the rotary machine with its electro-pneumatic circuit. Each one of the actuators represents one of the stations. Each one is labeled, so everything is being controlled by using a virtual PLC, and where the code was written in codices, and we're actually controlling this from a control panel that we're going to see later. Right now we stop the cycle by using the visualization in codices, and we can see how the circuit is answering. We are resetting the pistons to their original positions, and then we are letting the process continue again. Now this is how I connected the Fluid Sim circuit with the PLC. I used 6 modules in order to connect all the different sensors and all the different actuators that I needed. So all the electrovalves are controlled by codices, and all the sensors are sending information to codices. This is a diagram I used in order to validate my code and make sure I was actually following the correct cycle, the correct process. like in real life. So it's a sequence that the machine is following. It's activating the stations one by one by using counters and enabled like flags. So we're using these flags in order to tell each station to turn on or off. So the cycle continues like this, and once it reaches this point, it means that all these stations have been activated, and thus the machine is working at full capacity. All the possible spaces are being occupied by one container, and all the stations are doing their process. Now here we can see the result of how the machine will be working with this proposed code, and as you can see, if we take a look, this is how the machine is working with at full cycle, right? And if we compare, we can realize that the code is actually performing correctly. There are no collisions between each actuator and the rotary table, which means everything is working fine. Now, this is the code. First, I defined all the different sensors as inputs for codices. Then I defined all the outputs for all the different suckers that are working in this project. After that, I defined all the different control buttons that we're going to see later on the visualization. And we begin with the enable of each station. As I mentioned before, I'm using flags and counters in order to tell each station when it's supposed to activate. Then we begin with the sensors for each one of the suckers to tell them when to turn on and off. And here the cycle begins. With the first station, it's supposed to place one container on the transfer table. The rotation of the table, filling the container with product, placing the lead and sheet, which are done by the same actuator, but the difference is that we activate the suckers independently, the seal of the container. And finally, we extract the container from the table. As we saw on the animation, first we lift and then there's an arm that pushes it from the table. And these are some things for the visualization: the temperature control, the pressure control. We are also counting how many products have been processed. Now let's take a look to the panel. We have a power control, an air pressure enable control, a temperature enable. Now we have a go, a stop, and a reset button. And finally, there's an emergency button that's going to stop completely the operation of the system. We can see a station status panel to the right. Each lamp is activating once the station has been enabled. And also we have a process units indicator that is telling us how many units have been processed. We can see how the process units keeps going on, and if we press emergency stop, we cut the air pressure, we turn off temperature, and we stop the machine completely. Well, we reset the process units just to show it's working. We reset the system so all pistons go back to the start positions, and we replace. That's why the lamps turned off, and now after we hit go, the process continues. Finally, in this diagram, we can see a plan for implementing this project in the industrial process. It begins with the analysis and description of the process, the analysis of process requirements. Then we move to analysis and definition of location of electronic equipment, hardware equipment, and software control selection, and preparation of electrical installation plans. Then we move to the analysis and development of process control operating algorithms. After that, we begin with the configuration and programming of the PLC and the SCADA equipment. And finally, the last 2 weeks will be of simulation, debugging, and function checking to be sure that the process is working correctly. Thank you very much for your attention.